Hello, and this is day 6 of 5 Steps to a 5. So we've got a graph. Before we read the question or even look what they're trying to determine what they're looking for, we are going to analyze it so we don't go down the wrong path. We use our process, Oyzerga, Oyxirga. Our origin, as far as we can tell, since there are no numbers, that is a 0, 0. The y-axis is velocity, and we're not given units. X-axis is time, not given units. And the intercept happens to be at the origin. That's critically important. And now what can we read from this graph? Any question about the instantaneous speed or velocity or the time is something we're going to read. The gradient of the graph is dividing the axes. That's delta v over delta t. And we should recognize that as the definition of acceleration. And the area is v times t, multiplying the axes, and that is meters per second times seconds, which gives us meters, and that is the displacement. So now we're going to interpret what is happening with each of these quantities. Reading, let's see, the velocity increases and increases and increases and increases, and then it starts to steady or even out. So it increases, then evens out. The slope is the acceleration. So here we've got a slope, here we've got a slope, a slope, a slope. So what's happening to the slope is the A decreases to 0 by the end of the time period. We might even say it's parallel at that point. Now the area is the displacement. So when we start coloring in the area, notice the area continues to increase. And the area is positive, it just keeps getting bigger and bigger. And even if this curve stayed horizontal, the area would keep getting bigger and bigger, which means that the thing is moving in the positive direction and it's continuing to move in the positive direction. So in one sense, this is like a car starting from rest, v0, increasing its speed, say from 0 up to 55, and then going on cruise control. Notice all that work we did before we even read the question. And remember, the guidance that we get even from Princeton Review is that 80% of our answers for questions should be the setup. So we're taking the time to make sure we get this right because there's so much at stake. So we got a live cart moving to the right, on the positive directions to the right. Haha, we already know this, and we know it speeds up, but eventually gets kind of steady with its speed. In a clear paragraph response, describe how the cart moves and how the graph indicates the motion you describe. Okay, include reference to the direction and whether the cart is speeding up or slowing down. So now what we should be thinking about is we're going to be writing an outline of sorts. What are all the things we want to say? We want to say it starts from rest. It accelerates in a positive direction. Its speed increases until it becomes constant. The acceleration decreases to 0. All right, so let's see now. Describe how the cart moves. We've described how it moves. It starts from rest, it speeds up, and eventually becomes constant in a positive direction. Okay, but now, how does the graph indicate the motion you describe? How do we start from rest? Well, let's add that information now. At t equals 0, v equals 0, and that's the y-intercept. Okay, it accelerates in a positive direction. Okay, acceleration is the slope. Slope is positive, decreases in magnitude until 0. The speed increases until it becomes constant. Boom, so we've just explained that from both of those. The acceleration decreases to 0. which we've also explained. And we've said how it speeds up. So now we've done our work and said everything we want to say. And then it becomes a question of how to write this as succinctly as possible. So we might start out as saying the cart accelerates from rest in the positive direction. Because the v at time equals 0 is 0, y-intercept, and the v is positive throughout the time period. The slope of the graph, acceleration, is steepest at the beginning, is positive, but decreases in magnitude to 0 at the end of the time interval. Thus, the cart increases its speed at a decreasing rate until it travels at a constant speed at the end of the interval. And now that we have this draft here, we might think about how we could polish this and make it simpler. And what we're looking for is 2 furs, or 3 furs, or 4 furs. And that is where we, in one sentence, we say 2 or 3 or 4 things, or we say something in such a way that it allows us to write it much more succinctly. The cart accelerates from rest in the positive direction because the v at t0 is 0, and the v is positive throughout the period. Slope of the graph is steepest at the beginning, is positive, is steepest and positive at the beginning. At the beginning, but decreases in magnitude to 0 at the end. Maybe we don't need to say the time interval. Thus, the car increases its speed at a decreasing rate until it travels at constant speed. And of course, we could work to polish that. But notice the process. We spent most of our time doing the work, intellectual work of analyzing the graph before we got confused by the question, or that stressed us out. And then we listed the things we wanted to say, went back and double checked against all the things it's looking for. And then we started a draft to make sure that we included everything with this. Now, I'll point out we've had a lot of conversations so far this year about indolence and accuracy and precision. And this going back and forth between what's expected of us and the final answer is essential in being able, in addressing these paragraph length questions. It's very easy to get started in our angst to move on and not do it. But in this case, it is much better to answer this question and get 5 out of 5 than to move on to the next, than to do a sloppy job, only get 2 points, move on to the next one and only get 2 points. We're better off committing that time here because we know the material.